Hi everyone, I'm Rahul Marala. Today I'll be presenting my project New York Housing Price Prediction under the guidance of Dr. Chavaji J. Wang. Introduction of the project. In this project, I aim to predict the real estate prices in New York, which will help the buyers, sellers, and agents to make well-informed decisions. And also, I've analyzed the data set with key features like bedrooms, bathrooms, square footage, and location. And also, using some regression techniques, I've identified the factors which are affecting property values, and also provided the insights into the market trends. Dataset overview. This dataset contains 4,800 rows with 17 distinct features. The dataset is sourced from Kaggle. Some of the key features of the dataset are price, bedrooms, bathrooms, property square footage, location details such as state, address, locality, and sublocality. The data pre-processing, in which I have cleaned the data by handling missing values and removing the outliers. And also I have created a new feature called price per square feet for better predictions. And in the data transformation, I have used one hot encoding to convert categorical variables into numerical format, and also selected some important features for our model by using some feature selection. Data analysis. In this, I have analyzed the distribution of key features using the histograms and bar plots to identify any skewness or outliers are there in our data set. And also I examined correlations to understand relationships between variables, how other features in the data set relate to the price column as it is our the target column, and also use count and bar plots for categorical data like property types. And also I have created a price per square feet column to see how values scale with the size across the different property listings in the data set. The next is model selection. uh, in the model selection, I have tested various regression models, which includes lasso ridge, XZ gradient boosting, random forest, etc. And also I have used the random forest to identify the important features in the data, which will help them to build the model for better performance. And also the models were evaluating using the root mean square error and R2 square values. These are the few key performing metrics which I have used to analyze the different models, which are among the 7 to 8 models I have used in my data set. So after tuning the hyperparameters, the XZ emerged as the best model. Like this is the graphical representation of all the models that are evaluated using the R2 squared and mean square error and the root mean square error. From this, XZ emerged as the best model. The website description, like the website is designed as user friendly using the Streamlit app, which helps for predicting the house prices based on the train model. So this website is designed in such a way that it allows the users can input some details like beds, baths, and square footage. And by clicking the predict price button, they get an instant estimate. So they can see the total price of the property, where it is located and which sub locality is located. And they can compare the prices with the other properties like condo, townhouse, or an apartment. Next, this is a command prompt. So for to run the Streamlit app, we use some commands to run this. We give some commands in the command prompt. This is the basic, like the web app for my project, like New York Housing Price Prediction, in which we can give the number of beds, baths, property square footage, and state, locality, and sublocality. By clicking the predict price, we can get the estimate total price. So I have given some values in the number of beds, number of baths, like number of bedrooms are 4, number of bathrooms are 3, and the property square footage. By declaring the state, locality, and sublocality, by clicking the predict price, we can get the estimate price. And there is one thing in this web app, like we can download the model for the offline predictions. Next, the conclusions for the project. Like finally, I have created a predicting model using the machine learning to estimate housing price predictions in the New York. And by performing the machine learning techniques on the data set, XZBoost emerged as a best performance model on my data set. And by creating like user-friendly app like the Streamlit app, which will help the users to get the estimated total price based on few based on few inputs. In the future, I plan to improve the accuracy by adding the real-time data. And let's go for the demo of our Streamlit app. So here I give a command in the command prompt to run the Streamlit app. So by giving this command, like this is the web app which I have created for my project. So here is the number of bedrooms, number of bathrooms, property square footage, state, locality, and sub-locality. So by we can increase or decrease the bedrooms, and we can increase or decrease the bathrooms. So it depends upon our choice. Like, so suppose I kept the four bedrooms and three bathrooms, and by giving the property square footage like 1500, and we can keep the state as New York, as this project is based upon the New York housing price prediction. Locality the locality New York City and the sub-locality Manhattan. We can predict the price, like the estimated total price is around $450,000, and we can change the number of bedrooms and number of bathrooms. Suppose I have increased the number of bedrooms and kept the number of bathrooms as three, so we can predict the price as the last three numbers has been changed. So this is a demo of my project. Thank you, everyone.